is also visible, guys, everyone? Quickly created a website with some name upside down. He's trying to sell some watches, I guess. Means within a minute you can now create these type of things and you can utilize this type of tool. So this is really great. Okay, I think the similar situation happened with Virendra as well. Virendra mentioned that you just have to cross the pro window. Tried it out. Most probably you would be able to do it. No, Debosmita, we cannot use the Manas AI without signing up or signing in because they are giving you complete projects. So it's good that you have already signed in. Devansh also created some craft wheel, which so with that link, it is technically just hitting that same amount again. You can see that they are doing the link that you share, it's technically sharing the if we click on this part, this is where we can see the demonstration of your application. Guys, see, this is how, means within a minute, we all were able to do this. Yes, Devansh, just click on publish and see if it is asking for any paid plan. Publish. If it is allowing you guys to publish your the websites, the web applications that you are developing without any paid plan, then this is good. You can in fact create projects and publish it, and you can demonstrate those projects. There are not many tricks, but we will be sharing those tricks. We can utilize this one. The time feels anything which is maintaining better quality, this would be a little bit slow. It's kind of the trade-off, guys. If you want something fast, their quality would be compromised. But if you are having high quality, that means would be a little bit time taking. But I think this is something that we highly recommended all of you do some projects, do something extra whenever you have time. Is I understand you won't be getting time in these 2, 3 upcoming weeks because you have your exam scheduled. Of course, just focus on your exam, get good marks, and once you are done with that, once you have time, just explore these things. You can explore Manas AI type of tools, create some projects, and the form that we have rolled out. If you think that it is okay to show it, share it, then just upload those things there. Also, keep a kind of repository, guys, everyone. If possible, learn how to use GitHub. If you are okay to use GitHub already, upload all of your projects as a repository on GitHub. Kind of create a complete portfolio. And every project that you are developing, you should have a history of it, maybe on GitHub or anywhere else. And every project, just share it on LinkedIn as well. And try to include as many people as you can. Okay, guys. Oh, Kanak, this is something that I thought you guys can do. Sujal, why do you want to take classes even after semester end? Once your semester is done, you will have some break, and then, of course, the next semester, next year will start, and they will announce the upcoming year and semester. Okay, guys, so just explore this type of humor. Now, let's move to our today's topic. Now, and let's start understanding what are the things that we are learning in these weeks. In the previous week, guys, I was not available, so I couldn't take your session. Sorry for that. But someone else took the session, and I hope you guys understood. I'll just give you an overview, and in fact, we can do some things where you get the clarity what exactly you are learning. So, technically, so you are learning the AI or the development of AI, which is rule based. And in this journey, first you learn the means hard coded algorithms. If you remember, guys, we learned things like A star and other algorithms, BFFs, all the search based algorithms. And then we that for the algorithm learn from the rule based intelligence conditional intelligence. This is where we started learning how probability can be utilized to create means self-decision ability. And then you learn the bias, rule and theorem and probability and how we can create or utilize it to create the artificial intelligence. This is where you learn the conditioning scheme. For example, how we can make an inference about should you take an umbrella or not based on a condition maybe clouds are there or not. Right? If you guys remember, we are doing these things. Now, after bias rule, there was another concept that you understood in the previous week. It was about Markov chain, right? this week you are learning in another algorithm which is called as hill climbing. Now, first of all, what these things are and where these things are being utilized. So if you guys remember, ultimately we are learning the game theory. Means in order to develop AI, the ability of self-decision, ability of self-decision, in order to develop this ability of self-decision, we started exploring the computer science branch, we started exploring some algorithms, use cases of algorithms. Means we also discussed, for example, if it is, let's say, TFS search, how this works and how you can utilize this algorithm in any real life use cases. Right? These were the things that we were doing step by step by mapping the things. For example, if this is the algorithm, then you can utilize it in real life use cases. So, in that case, we discussed that we can call it as an agent which is taking decisions. Now, there are some rules on the basis of which agent takes the decision, and most of the use cases that we could find of this type of rule-based AI was about the gaming environment. Right? That is why in the beginning, when the AI was just taking the shape, we were developing the agents who are able to play the game. Who can play the game by taking this self-decision, this artificial intelligence, along with some other players. Right? So we could see that initially some IBM developed any type of AI which could beat the world chess champion and things like that. Those things were happening. Right? So now you understood that this full game theory works on basically two major components. Means there will be some environment and there will be an agent who is taking some actions on that environment. And based on this action, that environment will change. Now we are having different algorithms which decides these actions, and based on these actions, we are having different states in our environment. Right, guys? We all are very much clear what exactly we are learning. I'll explore all of your applications. So technically, this is what is our objective. We are running a rule-based AI, and AI means it works on two components, agent and environment. Environment is the space where agent is taking any action. Now that action is being governed by the algorithms. And based on the actions, environments are having different states. So with the help of this type of arrangement, we were able to create the rule-based AI, or we were able to simulate the intelligence which is able to take the self-decision. Right? Now, in order, in this same order, where you learn the algorithms, initially the core algorithms, then you learn the probabilistic algorithms like the bias theorem, or you can utilize the bias theorem and bias theorem. And now, after that, you also understand there is a one another kind of algorithm which we called as Markov chain. This is something that you learned in the previous session. And another called as hill climber. Now today we will focus mostly on hill climbing algorithm, how exactly this works. But yes, we will also simulate what exactly is Markov chain algorithm or Markov chain method of achieving the rule-based AI. So to do this call, just let me know guys, raise your hand if you can explain what exactly is hill climbing. Raise your hand guys. Just let me know. Harsh, really good. I like that idea. Amit, I'll see that link as well. Oh, Sujal, you quickly developed an LMS. Guys, raise your hand if you can explain what exactly is hill climbing. Raise your hand, guys. Okay, one above. Others, guys, where are all of our active students? Okay, Sujal, two, two students only. Only two students can explain what is hill climbing. Why students? Good, Divansh. Three people. Vivek. But still, our all active students only. These are our regular students. The regular active students. Okay, so we can start from Devansh from you. Yes, Devansh. Devansh, you can unmute. Yes, Devansh. Now,
Hill climbing is an organization problem. It works like it basically looks at our current situation and checks all the options. And it moves further if there is a better option or a better option than our current one. And it repeats again and again. And it stops if there is no better option available. And there are two types of hill climbing, like simple hill climbing and sleepless ascent hill climbing. It are variants of hill climbing. The simple hill climbing is like it examines neighbors randomly until there is improvement and stops if there is no improvement. And steepest ascent is it evaluates all neighbors and chooses the best one.
the gist of this is this. Vivek, Yes, Vivek.
Good morning, sir.
Good morning.
Yes, sir. Means hill climbing is like a search algorithm in AI, which helps to find the best optimal value by choosing by neighbors. Means ये क्या होता है बेसिकली अपने नेबर से सर्च करता है if बेस्ट ऑप्टिमल मीन्स या तो बेस्ट मैक्सिमम वैल्यू मिल जाए या फिर बेस्ट मिनिमम वैल्यू मिल जाए वो चूज करेगा और अगर उससे बेस्ट है आसपास नेबर्स में तो वो चूज करेगा बट इट इन नॉइजी डाटा and if there are many ups and downs in the graph of data then you can start.
Okay, then good. Guys, can anyone mention means we already have some search algorithms. What is the main difference between, let's say, A star and the hill climbing? Or what is the need of hill climbing when we have A star? Can anyone answer this question? Very good. Sujal? Sujal, you can unmute.
Yes, sir. Good morning.
Good morning.
सर मुझे क्वेश्चन में कौन सा हिल क्लाइंब सकता है
Okay. But think of this, guys. Means now we understand, okay, this is hill climbing. We also understood what is A star. We know that both are search algorithms. But what is the need of hill climbing when we already had A star? We discussed that A star is the best one, A star it gives the best optimized path and all these things. Then what is the need of hill climbing? Praveen?
गुड मॉर्निंग सर
Good morning.
एक्चुअली जो ए स्टार एल्गोरिथम है उसके लिए हमें मेमोरी की जो रिक्वायरमेंट है वो ज़्यादा होती है एज कम्पेयर टू हिल क्लाइंबिंग तो इसलिए हम हिल क्लाइंबिंग को मतलब जो है यूज़ करते हैं इसके अलावा इसमें ये देख सकते हैं कि ए स्टार जो एल्गोरिथम है वो थोड़ा सा स्लो होता है एज कम्पेयर टू हिल क्लाइंबिंग
Very good. Very good. Both of the points are absolutely correct. But I would say both of these points are effect of one cause. What is that cause, guys? These two points are absolutely correct. But why? Why A star takes more memory? Why A star takes more time?
सर ऐसा कैसे जैसे जो ए स्टार एल्गोरिथम है उसमें जो बेस्ट ऑप्टिमल सॉल्यूशन होता है उसी को जल्दी से सर्च किया जाता है एज कम्पेयर टू हिल क्लाइंबिंग में जो है जल्दी से बेटर रिजल्ट आएगा ऐसी कोई गारंटी नहीं है मतलब इसके पास में बेस्ट सॉल्यूशन की कोई गारंटी नहीं है इसलिए
Yes, correct. Ashutosh?
सर ए स्टार में टोटल कॉस्ट जैसी चीज़ थी जिसमें सर टाइम और कुछ ऐसे से कोई एक फॉर्मूला था जिसमें अगर है तो सर टाइम जो था वो ज़्यादा लगता था तो सर उसके हिसाब से ए स्टार थोड़ा स्लो हो जाएगा शायद से
Hey guys, don't get confused with total cost type of thing. That total cost is everywhere. Means whenever you are moving from one state to another state, you will be investing something. So there would be a cost of that. Means let's say if you are moving from point A to point B. So cost can be how many kilometers, cost can be how much, let's say time taken, cost can be anything. And this is everywhere. In fact, we will discuss I'm just looking for one. There is a major difference between A star and this hill climbing. That major difference is means touched by Abdul Tayyib chart answer. Devansh?
Yes, sir. Sir, A star basically checks more things, which is why it scores more notes and asks more time. But hill climbing looks good near key neighbors. That is why it is called an A star.
Yes. So this is exactly what I was looking for. But we can use a different words. In fact, we should use a different words. What are the different words? Is see A star or the type of other algorithms. They were trying to access the full tree, means all the possibilities. Let's say there are some nodes, some edges, something like this. Means a too complex thing. I'm not wasting time to develop any graphs. Let's just assume that it's a too complex thing. Now all these algorithms, they try to access the full tree. They will go through each of the every node. Right? And that's why, because they are trying to access every node, they are trying to access the full tree of the environment. So if you remember this, when we were simulating these algorithms, so we were having some this type of environment where the blocks were there and we had to move from one point to another point. And you created some resistance in between. So it moved block by block by block, and then it was trying to find an optimal solution between initial state and the final state. In this process, if you remember, all the other algorithms were trying to access each and every point. It's just how they work that was affecting whether some part of the environment will be accessed or not. But their objective was to access every node, right? So all those algorithms, their objective was to explore full tree. I would want to use this phrase to mention this. All those algorithms, because their objective keeps a fundamental component as they always want to explore the full tree. That is how they can find the optimum solution, right? Because they know all the other solutions. But this hill climbing, this says let's not worry about possible means transitions. Just start from a random place. It's just allow me a second.
Mhm.
So it is, I usually don't pick anything while I'm having only thing if it is a personal, I'll take it. So we were discussing how this hill climbing came into the picture. All the other algorithms they try to explore the full tree, but this hill climbing says, let's not worry about the full tree. Just start from any random point and then follow a greedy approach. So, Vivek, just a minor correction in your answer also means it never looks for minimum value. It always looks for maximum heuristic function. I'll discuss what this heuristic function is. In fact, you don't worry about this word at all at this moment. Just assume that it always looks for the maximum value. Now, what this means and how this will work, it always works in three steps. Step one is initializing any random state, then move to a neighbor which ensures the maximum number. And then third, evaluate. Evaluate means if there is still another move that is required, and if required, do we have any other neighbor which is having more value than the existing value? And based on these things, it will evaluate and take another decision, then another decision, another decision. If there is no any neighbor with the more value than the existing state, then it stops. So you can think it as a three-step process, the hill climbing. Now, I'll take an example there. So you will get this uh, clarity how this hill climbing works. With the most famous use case is the queen placement. So we say that if there are two queens together, they will attack each other. Right? Now, what this means is there are some rules. The rule says if there are two queens in a single row, they will attack each other. If there are two queens or more queens in a single column, then they will also attack each other. If there are two queens, two or more queens, diagonally, then also they will attack each other. Right? So we are creating a kind of environment. Let's say you have an environment. I'm just drawing so that we all can visualize this hill climbing, guys. Let's say you have some 3 cross 3 or something like this. So this is 0 0 position. This is 1 position. This is 0 position. Means zeroth row and this is zeroth column. Right? So this will become 1 0. This will become 1 1. This will become 1 2. And similarly, this will become 2 1. This is 2 2. This is 2 3. Now, how hill climbing works is, let's say now your objective is to place the, let's say 3 queens are there, right? You have to place 3 queens in this environment in such a way that they are not attacking any queen is not attacking each other, right? Sujal, any question? Yes, 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 correct. So this is technically 2 0 1 and 2 2, right? So our objective is what? We have some 3 queens. We want to place them on this arrangement in a way that no queen is attacking any other queen. We know that if there are two queens in a single row, so they will attack each other. If there are two queens in a single column, then they will also attack each other. If there are two queens diagonally, then they will also attack each other alongside, then again they will attack each other. There are 3 groups.
Hmm.
So if let's say you place one queen here and another queen is here, they will attack each other because they are in the same row. If one queen is here and another is here or here, again they will attack each other. If one queen is here, another is here, they will also attack each other. Right? So now how hill climbing algorithm works? It says, okay, first of all, just randomly create a state. So hill climbing, it will randomly create a state. So maybe let's say it is placing queens like this, right? This is the first state. Now, what is the heuristic or the cost function? Just now assume what is the cost function. Cost function is in this case comes as how many queens are attacking each other, right? So see, this is diagonally, so they will attack, and this is in a single row, so they will also attack. So technically, my cost function, if I say it as h, so it's 3 at this moment. There is another real use case. So this cost function will be mapped according to that use case. At this time, we are taking a use case as how many queens are attacking each other. So that is the cost. So now the objective of hill climbing algorithm is to make shifts in the position of these queens in a way that this h becomes 0. Means no queen is attacking each other or any other queen, and you have to follow these rules. They should not be in a single row, they should not be in a single column, and the hill climbing always walks in a greedy way means it always try to find the neighbor which has more value, right? So more value is not like, for example, here if you want to move the next stage, the hill climbing initialize, this is the first step. It has initialized a random state. All three queens placed like this. But now cost function comes as 3. We have the objective as cost function should be 0. Now how this will take the second step? So for example, it can pick any queen, right? Queen 1, queen 2, queen 3. It can pick any queen and all the neighbor positions. It can move it to any of the neighbor position while following a greedy approach means this should give us a maximum number in a way that h reduces to 0 or less than what is there or what is currently there. Means, for example, let's say we move this queen to this position, right? This is the first transition. Now what happens? Your h becomes 2. Means this queen is not attacking to anyone because there is no one in this row and column and row. And this queen is also not attacking anyone until this third condition that there is someone diagonally, right? Now, logically, guys, we have taken this 3 cross 3 environment a little shorter to maintain this condition. Means you cannot find any position for 3 queens in 3 into 3 environment so that they cannot, because there are only 3 rows. So we need more number of rows and columns. So let's say this is 3 0, 3 1, and 3 2. We have increased one row. Now let's say we shifted this to here and still h is not 0. H is 2. Means these two queens can attack each other. Now let's say you pick this queen and you shift this queen in the second row at this position. Right? Now if you see this queen is not attacking anyone, this queen is not attacking anyone, and this queen.
This meeting is being recorded.
Now, technically, in hill climbing,
This meeting is being recorded. This meeting is being recorded.
so only because we created a new
This meeting is being
environment,
recorded.
that's why we were only able to visualize it. Otherwise, technically, you will move it to another way in the upper direction. That is how you will be able to visualize the hill climb. Okay, the kilometer is going up. And means this is how hill climbing works. Now you could see that this is not means considering the all possible solutions, all possible states. Means it doesn't worry about how many those solutions exist. Right? It starts randomly from one place and then it follows some rules, that is hill climbing rules, and then it tries to reduce the cost, right? Whatever is the objective. This is your hill climbing algorithm. Now, um, first thing, guys, that comes up here is that this is not worrying about how many solutions exist, which one is the optimized solution. It is just means getting the objective done. practice the those algorithms, our this type of algorithms, and this hill climbing, because these explore the full tree, and this only achieves the objective directly without worrying about how many possible solutions can be there. That's why this takes more memory, this takes more time, because it is exploring full tree. What are all possible solutions? And this takes less memory, this takes less time. But here we get a disadvantage is there might be, that is what type of this graph is being shown, which says this is local maximum, and this is global maximum. So what this means is because it is starting randomly from any position. If let's say it is starting randomly from this position, so it would be able to detect this maximum, right? And this is the global maximum, then this is fine. But if let's say it is starting from this random position, right? So it will fetch, or it will means finalize this maximum as the final answer instead of this global maximum. So what this technically means is there is better optimum solution available. There is better optimum solution is available, but your hill climbing algorithm is not able to fetch that. Right? Means, let's say in this example, in this example only, let's say finally we placed queens one at this point, one at this point, one at this point, one at this point. This is the final solution. There could have been a much better solution to this placement, but because we are using a hill climbing, so we are not guaranteeing that this is the best optimum solution, but we are giving it as a solution. This is also possible. Now, hill climbing also only focuses on completing your objective. Your objective is to reduce this edge to zero. Means no queen should be able to attack any other queen. This was your objective. Now, to fulfill this objective, there can be an optimum solution, and there is a chance that you can find that optimum solution with the help of hill climbing if the random first initialization is somewhere around global maximum. Otherwise, you will find some another solution which is not the optimum, but this is solution. That is also fine. Your objective is completed. Right, guys? Now we make question.
एक्चुअली मुझे पूछना था जो सर क्लास मेडिकल्स वगैरह करवाते हैं मेंस जो भी है वो एग्जाम में भी आएंगे क्या?
आप कौन से सब्जेक्ट की बात कर रहे हो?
मैं वही कहीं बात कर रहा हूँ जैसे आपने एक प्रॉब्लम वाली बात करी तो बेसिक नेटवर्क फॉर्मूला वगैरह यूज करे हैं उसमें उसमें मैट्रिक्स वगैरह भी यूज करे हैं तो क्या वो आएगा
Means I cannot commit anything because this paper is being set by your professors. They can include anything which they are including in the recorded lecture. ये तो मान के चलो. Means they have means they can include anything which they have taught in their recorded lecture. But
एक्चुअली वही थोड़ा एक वीक पार्ट है
क्यों हुआ? If you guys understand the concept, then the mathematical formulas are just the derivation of those concepts. If you remember when we did the bias rule, we did not memorize the formula. We logically kind of derived it. This is what this means. Yes, right?
क्वेश्चन वगैरह करना पड़ेगा उसे। अगर कंफर्म हो जाएगा तो नेक्स्ट क्लास अगर बता दीजिएगा तो प्लीज बता दीजिएगा।
नहीं, वैसे पूछ सकते हैं प्रोफेसर से, बट गाइस जो भी रिकॉर्डेड लेक्चर्स में है सबके लिए प्रिपरेशन करो, राइट? Yes, Abdul so usually I just took 3 queens example, but the most famous example is about 8 queens. In fact, you will see there are lot many uh, visualization type of web links available on the website where you can see the queens moving one position to another. Right? A lot many students shared the Manas AI activity. Up to tab, how h value is more than 8 and the number of queens is 8 is means technically how many instances of attack is possible. Means if one queen is able to attack on 3 other queens, so it's not just one queen, it's 3 instances of attack possible. That is what is being considered as a total cost there. Yeah, means technically hill climbing, you can visualize it like it always moves upward. That's why its name is hill climbing. It always moves upward means it has a greedy approach. Means it always finds that neighbor which has the highest value. So the upwards neighbors will have higher value and lower neighbors or backwards neighbor will have lower values. But hill climbing always moves in the higher value positions. So it is always going either upward or the frontwards, not downwards or backwards. Go ahead, I will check this portfolio that you created with Monastery. In fact, a lot many students created good type of Manas AI. Okay, guys. I hope now we are getting clarity about this hill climbing algorithm. What exactly is this? Why we are using it? Even when we had A star type of algorithms. And once you have got this clarity, guys, so just raise your hand if you don't understand what is Markov chain. I'll quickly explain that also. Raise your hand, guys, if you either don't understand what is Markov chain or you want me to explain what is Markov chains. Raise your hand, guys, if you either don't understand what is Markov chain. Okay, fine, fine. Okay, guys, thank you. You can lower down your hands. And if we are having this Markov chain discussion, let me share this visualization, guys. We all can open it up. This is a very good visualization and you can customize it also. For Markov chain, what is Markov chain is? So technically, when we discussed, wait, yes, we learned some algorithms which always works in a definite process or the steps. Means the steps are definite. And then you moved to some other types of concepts where the steps are probabilistic, right? Now, the probabilistic steps, in those cases, is of course the agents and environment things comes. So there are some probabilistic steps which are means the current state. So there are some probabilistic steps in a way for which the current state depends on all previous states. It means, for example, let's say the game of chess. In game of chess, move which comes on, let's say, 67th step. This depends on every move which has been there from 0 to 66th step. Right? Means there are some environments where the current state is dependent upon all the previous states. Means whatever is the move in game of chess, let's say, at 67 position, 83rd position, any position, that depends on every move till then. From 0 to 7. Means the 33rd move is being affected from every move from 0 to 32. And then there are some environments is only dependent on one previous state, not on all of the previous states. So this Markov chain, if you look at this visualization, this Markov chain is an algorithm which works for this type of environment where your probability of current state is only affected by the probability of initial, just one initial data state, but previous state, one previous state only. So we call this as a transition probability. In fact, if you guys just look at this visualization, just guys take 2 minutes and read out this text. You will get exactly what is Markov chain. Anyone read this out? Who you had something else to say? So guys, what this says is a Markov chain is a probabilistic model describing a system that changes from state to state, into which the probability of the system being in a certain state at a certain time step depends only on the state of the preceding time step, right? Means if you talk about what is the probability of the current state, so this is only affected by the probability of the previous state. In that type of environment, in that type of system, we use this multi-proof chain. The probability that the J is the next state of the chain, given that the current state is I, is called the transition probability. And this is the probability that we usually call as transition probability. Means this current state probability is only dependent on the previous state probability. That's it. What happened to that previous state is just is not being considered for Markov chain simulation or Markov chain type of algorithm. Right? Now, if you look at this visualization, you will see we have some five states. State 0, 1, 2, 3, 4. Right? And based on these five states, we have five rows and five columns. And in each one, we have the probability of its transition state. Or transition probability. What this means is this is 0 through 0th column. So it says from 0 to 0, the probability of moving from 0 to 0 is 0.6. So if you look at this visualization, graphical representation, you can see that there is an edge from 0 to 0. And this has 0.6 probability. Means the 60% of the chances if your algorithm is at node 0, so 60% are the chances that it will come back to the same. Rest of the 40% are chances that it will go to 1. And then there are 0, 0, 0 means there is 0% chance that this will go to 1. And you can see there are no edge from 0 to 3. There are no edge from 0 to 3. No edge from 0 to 4. Reverse is there, but 0 to 2, nothing. So what this means is, from this state, the probability of moving to this state is 60. From this state, probability of moving to the same state is 60%. Right? And if you click on run, so this Markov chain runs in an infinite motion or step-by-step process based on these probabilities. Because these are probabilities, so these are random. Means from 0, sometimes it can go to 1, sometimes it can just be on the 0. If you click on run, you will see this Markov chain in action. And if let's say we stop it at any place, so if you consider these probability for these nodes and edges, then after 59 steps, everything depends on this transition probability. Now, if you want, you can change this value. Let's say from 0 to 0, we make it 0.2. But just ensure that each row has complete one probability. It should be complete one probability for each row. So this is 0.2, this is 0.4, only 0.6, 0.4 still you need to fill something. So let's say we say that probability of moving from 0 to 3 is 0.4. So you can see edge is and if we create for 4 also, so you can see another edge was created. Now you have changed the transition probability from node 0. Now reset, click on reset and then click on run again. Now, after this updated probabilities, if you again go and let's say run it for some 50, 60 steps, this Markov chain, and then click on stop. So you will see now the node 4, node 3, they are being vested more. This is another element which we utilize for some use cases, which is working on this transition probability. This is Markov. Right, guys? Now just do one thing before we move on and we wrap our today's session. As I promised, that last 10 to 15 minutes we can discuss important subjects. So just before wrapping it, guys, I will want you to share a game with you which simulates these concepts only, which we are discussing, the Markov chain and the hill climbing, especially the hill climbing. Everyone, guys, just open it up. This game is named as AI Dungeon. Open it up. Everyone, open up this game. Click on this play button and click on this quick play option.